this is a very quick systems diagram of how the Quant model works. I usually say it's got 3 parts to it, but most of those parts are irrelevant because one part is just a website. It's a fairly standard thing. The center section is about mapping, and the final section is about the web services. Now, I referred to this as immediate urban modeling or urban modeling as a service. I'll come back to that in a minute, but I wanted to just mention that the DAFNI spend for Quant for the UCL center is 5 NVIDIA V100 GPUs. And what you missed Mike saying was that we run a lot of Allpairs shortest path. So we have 3 modes in our Quant model. We have road, we have bus, and we have rail. And the road network has got about 7 million edges it's a road model for the whole of the UK, basically. The rail is the simplest one. It's probably only got about 10,000 edges. And the bus is somewhere in the middle at about 500,000. So you can imagine we've got a model with about 8,400 zones. We've got 8,400 zones to any other of the 8,400 zones. So to put it mildly, we're running shortest paths on a 7 million edge network with 72 million paths to calculate. And when you're looking at things like HS2, it can have a huge impact to the whole of the country. We can't just rezone the model. So what we've been looking at is how to do this faster. So this is what the NVIDIA GPUs will do. It's also important to point out that this could be construed as like a local version of a DAFNI node. The reason we have to do this is because we don't authenticate the users the way that DAFNI does. I noticed one of the questions was about how do we look at DAFNI, how do we look at models? Quant is completely open to the public. It's just a website, and it will always be open. So we don't authenticate, so we've got a separate, sandboxed set of hardware. So the idea is that we present these web services which run our Quant model. So looking at the right-hand side of the diagram now, you see the visualization outputs. I've got a 2-dimensional map there. So the green map is normally what you would see from the Quant website. But you'll also notice that I've got a 3D map. Now, this is my colleague Flora Rampani's work, who's now working at the Turing. But this was part of her PhD. This was a city engine model. So by exposing the urban modeling as a web service and by having immediate urban modeling, so we're interested in things that we can run in seconds rather than spending overnight running models. So we're interested in computational performance of urban modeling because you need it to run something like a 3-dimensional workflow like the city engine you see here, which is a retail model for the Olympic Park. So this was actually being developed as the Olympic Park was being built. Then on the right-hand side there, you see the idea is to buy a lot of high-end visualization kit. So we've got Alienware workstations and VR. So as well as pushing to City Engine, we can also push to Unity. So the idea is to use a Unity model with the VR kit. We've got a Vive kit there, HoloLens or Oculus. We're looking at these different types of visualization platform. The other thing that was going to be in Mike's presentation, which you probably couldn't see, was we were going to do a presentation where we have a touch table. So we have, I think it's a 72-inch touch table that we can stand around. So you can have people standing around the map, making interventions to it, and then discussing what those interventions actually mean, as well as merging that with the VR kit. So we're looking at VR and AR to augment what you see on the table with additional information. Okay, and with that, I think that's enough, and I'll hand over to the next presenter.